Okay, today's lesson is going to focus on the derivatives of the inverse trigonometric function. So this is your packet that you're working on, and the first thing we're going to do is fill in the 6 inverse trig derivative rules, starting with inverse sine. So the derivative with respect to x of the inverse sine of u, meaning the inverse sine of anything, is going to be given by this formula. 1 all over the square root of 1 minus the quantity of u squared times the derivative of u with respect to x. Next we have the derivative with respect to x of the cosine inverse of u. That's the same formula as sine, but the top is actually -1. So -1 over the square root of 1 minus quantity u squared times du dx. For the derivative with respect to x of the inverse tangent of u, we're going to have 1 over 1 plus quantity u squared times the derivative of u with respect to x. For inverse cotangent, same as inverse tangent but with a negative, so -1 over 1 plus u squared times du dx. For derivative with respect to x of inverse secant of u, it's 1 over the absolute value of u times the square root of u squared minus 1 times derivative of u with respect to x. And finally, derivative with respect to x of cosecant inverse u, -1 all over absolute value of u times the square root of u squared minus 1 times du dx. So this set of derivatives is one of the harder sets to memorize. I think these are harder than your regular trig functions just because of the square roots. You see how some are positive and negative. Some on the bottom here go 1 minus u squared, some go u squared minus 1. So this is going to take some memorization strategies on your part. But now I'm going to show you how to use them. So if you look down here at example 1, it says given y equals inverse sine x, find the derivative of y. So if we want to find the derivative of y, that's going to be dy dx. And now we're going to find the derivative of sine inverse x. Because it's sine inverse x, x is our u in this situation. So if we trace back up here to formula number 1, we're just going to kind of plug and chug here. Let me highlight that. So the derivative of the sine inverse of u is 1 over, so 1 over square root of 1 minus, now we're going to plug our u in and square it, so x squared times the derivative of u. Well, the derivative of x is just 1. So the final answer, if I take 1 times 1, that's 1, all over the square root of 1 minus x squared. This is the answer. Now, I'm going to show you why. This is actually going to be the only formula, number 1, that I prove to you. The other 5 I'm not going to prove. I'm just going to have you take my word for it, but I will prove number 1. I'm actually going to do that in the next video, though. So for now, we're going to actually skip the second page. So if you flip in the next video, I'll tackle why the derivative of sine x is what it is. For now, let's actually go to page 3 and take a look at your homework assignment. So your homework assignment for derivatives of inverse trig functions are going to be these 15 problems. It's 1 to 8 here, and then you flip it over, and you have numbers 9 to 15. An answer key is also included on the back page of this packet. But let's just take a look at number 6, for example. I'm just going to randomly pick number 6. Let me bring that up here. Okay, so for number 6, we've got y equals secant inverse of 2x to the 5th. So all you have to do is pan back to your secant inverse formula, and that says this. I'm going to write this to the side. The derivative with respect to x of the secant inverse of u is 1 over the absolute value of u times the square root of u squared minus 1 times du dx. So, using that formula, with this guy right here, 2x to the 5th, as our u, I'm going to take the derivative. So, dy dx equals 1 all over the absolute value of 2x to the 5th times the square root of 2x to the 5th squared minus 1 times the derivative of u, and by the power rule, the derivative of 2x to the 5th is 10x to the 4th. So cleaning it up, we have, I'm going to take 10x to the 4th times 1 to get 10x to the 4th. On the bottom, I'm just going to leave this as 2x to the 5th square root. I'm actually going to square this out. 2x to the 5th quantity squared is going to be 4x to the 10th, and then my minus 1. And this will be my final answer. And now if I check on the answer key page, number 6, I'll see right here, number 6 right here, you're going to see that the answer is the same as what we had, 10x to the 4th over the absolute value of 2x to the 5th times the square root of 4x to the 10th minus 1. So this is derivatives of inverse trig functions part 1. When you watch part 2, you're going to get the proof of why the derivative of sine inverse x is what it is.